Okay, so we went through all these metric units here. We put them up on the board. Let's take a look at how things work within our metric system now. Like we said, there's only the one main unit for each item we're going to measure. The meter for length, the gram for mass, and the liter for capacity. And we have all these prefixes that change the size of each of those for things that are smaller or larger. Our conversions within the metric system are actually quite simple. The way I was always taught to convert, which requires that you have this chart in front of you, unfortunately, is just use movements on the chart. For example, if I have 3.2 grams and I want to convert it into milligrams, I look at the chart. To go from grams to milligrams on the chart, I have to go 1, 2, 3 spots to the right. So I'm going to take my decimal point in the 3.2 and I'm going to move it 1, 2, I'm going to have to add a 0, 3 spots to the right. That is 3,200 milligrams. If I wanted to convert 2,800 microliters into milliliters. To get from microliters to milliliters on my chart, here's micro. I have to go 1, 2, 3 spots to the left. Even though those spots are empty, they're still place values. So I take my decimal point in the 2800 here and I move 1, 2, 3 spots to the left. 2.8 milliliters. So that's one way of making our conversions in the metric system, is to just use movements or places on that chart and move our decimal point the same direction in the same amount. The other way we could do it goes to our metric or scientific notation that we discussed briefly last class. I'm going to take this out of the way here for a second. Our main unit is 1 unit. We can think of that as being 10 to the 0. Anything to the power of 0 is 1, as we saw last week. 10 then is 10 to the 1. 100 is 10 to the 2nd. 1,000 is 10 to the 3rd. Mega is 10 to the 6th is a million. Deci, 1/10 is 10 to the negative 1. Centi, 10 to the negative 2. Milli, 1,000th, 10 to the negative 3. And 1/1,000,000th is 10 to the negative 6. So if I want to do my conversions, I can use those powers of 10. So I can look at, let's take 5.07 milligrams and convert into grams. Well, what power of 10 is milli? It's 10 to the negative 3. Grams are 10 to the 0. So we are converting from 10 to the 3rd to 10 to the 0. How many units is that? How many powers is that? Well, negative 3 to 0 is 3, right? So each of those units in the power is 1 decimal place. The question is, which direction? Well, what number is bigger, negative 3 or 0? Now be careful here. 0 is larger. So we're going from a small number to a large number. If the unit is getting larger, the number has to get smaller. So in our 5.07, we have to make this smaller so that the unit can get larger. And we're going 3 powers. So we have to go 1, 2, add a 0, 3. So this is 0.00507. Now I'm going to scroll this chart off the page right now for lecture, but if it's in your notes, keep it handy where you can see it, hopefully. If I have 0.032 liters and I want to convert into milliliters, Well, liters are 10 to the 0 because that's my main unit. Milli is 10 to the negative 3. Which one is larger? 0. So we're going to a smaller unit. If the unit's getting smaller, the number has to get bigger. By how many place values? Well, from 0 to negative 3 is 3. So we have to go 3 decimal places larger. So 1, 2, 3. That makes that 32 milliliters. (1800) micrograms to milligrams. Micro is what power of 10? Negative 6. Milli is negative 3. That changed by 3 again. Did it get bigger or smaller? Bigger. From negative 6 up to negative 3 is getting bigger. The number then has to get smaller by 3. So the decimal point starts here. We go 1, 2, 3 places. 1.8. Does that make sense? Okay. Personally, I prefer to use the chart. That's the way I was always taught. And I have the chart memorized, so it makes it easier for me. The book tends to focus more on the powers of 10 as its conversion. Now, we can also look at doing dual unit conversions. We'll run into things like, I don't know, 3.8 milliliters per hour, and want to know what's that in microliters per minute. To convert something like that, we have to remember that this is 3.8 milliliters per hour is 3.8 milliliters over 1 hour. So we're changing 2 units. We're actually doing 2 conversions here. We're changing milliliters into microliters. So let's do that. What is the power of 10 for milli? 10 to the negative 3. For micro, 10 to the negative 6. The power is getting smaller, so the number is going to get larger by 3. So 1, 2, 3. You have to add zeros. That would be 3,800. But now we also have to convert the 1 hour into minutes. So we're going to have to do 1 hour over 1 times, now we're on bottom, minutes on top. 1 hour is 60 minutes. So the hours cross cancel. 1 times 60 minutes is 60 minutes. 1 times 1 is 1. So our 1 hour converts into 60 minutes. Well, we're not done yet. We have 3,800 microliters per 60 minutes. We need to divide that down to make it a unit rate like we talked about last week. How much is that going to be in microliters per minute? So we're going to take our 3,800 and divide by 60. 63.33 microliters per minute. Now that one kind of combines standard units with the metric units with the time. Of course, time is kind of universal, metric or standard. But we might run into things like 750 grams per liter, and want to convert it into milligrams per milliliter. So again, 750 grams over 1 liter. We're changing into milligrams per milliliter. Grams is 10 to the 0. It's our main unit. Milligrams are 10 to the negative 3. Unit getting bigger or smaller? Smaller by 3, from 0 to negative 3. So the number gets larger by 3. 1, 2, 3. We're adding 3 zeros. 750,000. From liter to milliliter. Liter is what power of 10? 0, because it's the main unit. Milliliter to negative 3. Unit, once again, is getting smaller, so the number has to get bigger. From 0 to negative 3 again is 3 place values. So the decimal point goes 1, 2, 3. We fill in with zeros. That is 1,000 milliliters in a liter. So we divide that back out. 750,000 divided by 1,000 is just 750 milligrams per milliliter. You'll notice that it didn't change. The conversion from grams to milligrams is the same as the conversion from liters to milliliters. We might convert 3.2 micrograms per milliliter. And we want to know what that is going to be in micrograms per liter. So we're going to set this up. 3.2 micrograms per 1 milliliter. Converting micrograms per liter. The micrograms don't change, do they? So that's going to stay 3.2. 1 milliliter to liter. Well, milliliter is 10 to the negative 3. Liter is 10 to the 0. The power is getting larger. We're going from negative 3 up to 0. So the number has to get smaller by 3. So we're going 1, 2, 3, putting those zeros in. That is 0.001. So now I divide that out. 3.2 divided by 0.001 is 3,200 micrograms per liter. Any questions on that? We could run into a standard units. We could run into things like a consumption of a material of 2.4 ounces per minute. They want to know what is that in pounds per hour. Well, 2.4 ounces over 1 minute. You want it in pounds over hours. Well, there's going to be a little, notice I left a little space here because it's going to take more than a single step here. First of all, we want to get rid of the ounces. So I'm going to put ounces on bottom, and we want the ounces to become pounds. And we do have a direct conversion. 1 pound is 16 ounces. So the ounces have canceled out. But we don't want minutes anymore. We want the minutes to become hours. So I'll put minutes on top, hours on bottom. The minutes will now cancel out. 1 hour is 60 minutes. So for this conversion, we have 2.4 times 1 pound times 60. 2.4 times 60 is 144. On bottom, we have 1 times 16 times 1 hour is 16 hours. If we divide 144 divided by 16, we will get 9. So it's 9 pounds per hour. So the standard units is a little bit trickier to do. Not just moving the decimal points anymore. Any questions so far? Okay. Well, let's move on then to some of our other things that we're going to talk about. We have to talk a little bit about converting between metric and standard then. And the conversion that we're going to be making a lot between metric and standard is pounds and kilograms. 1 kilogram is approximately 2.2 pounds. It's actually like 2.206 or something like that. It's 2.21 something. But for our purposes, 2.2 is close enough. Most of our medicines now, the dosages are based on kilograms, not on pounds. So if a patient comes in at 198 pounds, to do a medical dosage, we have to convert that into kilograms. So just like any other, we're going to put it over 1. And our conversion factor, what's going to go on bottom? Pounds, so we can get rid of pounds. Kilograms will go on top. What's our relationship between kilograms and pounds? 1 kilogram, 2.2 pounds. So 198 times 1 kilogram is 198 kilograms. 1 times 2.2 is 2.2. 198 divided by 2.2 is 90 kilograms. So a 198 pound patient is a 90 kilogram patient. This conversion is one we do often enough that rather than go through the whole conversion factor, you can just look at it and realize kilograms are bigger than pounds, the number is going to have to get smaller. So if someone comes in at 154 pounds, rather than setting up the conversion factor, what are we going to do to the 154? We're just going to divide by 2.2. 154 divided by 2.2 is 70 kilograms. You have a patient that comes in at 165 pounds. How many kilograms are they going to be? What's it come out to be? 75? 75 kilograms. Good. If a patient comes in at 40 kilograms, how many pounds are they? You're going to multiply by 2.2, which will give you 88 pounds. Very good. That's really the biggest part of our conversions that we need from metric to standard is the kilograms to pounds. There's some stuff in our apothecary units and stuff like that. For example, 1 milliliter is approximately, or sorry, 4 milliliters, I should say, is approximately 1 fluid dram. Now, we haven't talked about a fluid dram yet. I've kind of avoided it because a fluid dram doesn't make any sense. 1 ounce is 16 drams, but 1 fluid ounce is only 8 fluid drams. Makes very little sense, but it's the way they set it up. Now, I mentioned minims and grains earlier. In our earlier discussion, we said minims and grains were part of the standard measuring system. But because they were used so much in in medicine, they were absorbed into the metric system for medical purposes because they just couldn't get rid of them. Originally, a minim, now minim sounds a lot like minute, so this would make sense. 1 fluid dram contains 60 minims. Minims, not minoms. Think, like I said, think of minute. There's 60 minutes in an hour. There's 60 minims in a fluid dram. Grains, I don't even know the conversion into the standard units anymore because they've been kind of twisted around. But in metric units now, 1 milliliter contains 16 minims. One gram contains about 15 grains. Now be very careful. If I were to write this out with abbreviations, 1 gram is 1 G like that. The abbreviation for grains, GR. Very, very easy and a very common mistake to look at GR and say, oh, grams. It's not. Grams is just G. So if you see GR, it is just talking about grains and not grams. So 1 gram is 15 grains. However, 1 grain is 60 milligrams. I'm going to pause there for a second. 1 gram is how many milligrams? 1,000, right? The definition of milli is 1/1000th. If I multiply these numbers together, what do I get? 15 times 60 is only 900. Something's off there. Well, they've adjusted the size of a grain hasn't adjusted because it came from the standard system. It didn't fit perfectly into the metric system. Technically, it's just under 16 grains in 1 gram. It's like 15.8. There's technically 1 grain is technically 62 milligrams, like 62 or 63, somewhere in between there, depending on which book you look at and how they round it. So if you were to do it as 15.8 and 62 point whatever, it does multiply up to 1,000. But because the grains are used so frequently and they didn't want those odd numbers in the metric system, they rounded them off to be 15 grains in a gram and 60 milligrams in a grain. If you are looking at an older textbook or a textbook that has a very traditional author to it, or even working with an older doctor, they may not use 60 milligrams as a grain. They may use 62 or 63, depending on what they were taught. So just so you're aware that that's out there. For our purposes, 1 grain is 60 milligrams. So if I have something that is prescribed as 3.2 grains, and I want to know how many milligrams that's going to be, how am I going to convert that? It's 3.2 grains over 1. Grains on bottom, milligrams on top. 1 grain, 60 milligrams. Cross cancel the grains. 3.2 times 60, 192 milligrams. 1 times 1 is 1, so it's just over 1. So 3.2 grains is 192 milligrams. Or I might have not to bring up something from the last unit, but here's something from the last unit. GRVI. What's VI stand for? 6. GRVI is 6 grains. When we use Roman numerals for specifying an amount of a medication, we put the unit before the number. So 6 grains going into milligrams. I do the same conversion. 6 grains over 1. Grains on bottom, milligrams on top. 1 grain is 60 milligrams. Cross cancel the grains. 6 times 60 is 360 milligrams. Other units that we cross over. Here's one that in the book, you're actually going to see it, two different numbers given. 1 fluid ounce. On one page in the book, it says 1 fluid ounce is 30 milliliters. A couple pages later, it says 29.9 milliliters. Technically, this is more accurate, but we're going to use 30 just to keep it simple. One teaspoon is actually really close to being exactly 5 milliliters. And then there's another unit that we use a lot called a drop. The abbreviation for drop is GTT. And a drop is defined on the thickness or the viscosity of the fluid that we are working with. The thicker the fluid, the fewer drops it takes to make a milligram or an ounce or whatever. If we're dealing with water, it is defined to be 1 teaspoon is equal to 60 drops. Again, that's for water. If we have something thinner than water, like alcohol, 1 teaspoon might be 70 or 80 drops. Something thicker, like a glycerin or something like that, 1 teaspoon might only be 30 drops. So now if you look at this, since 1 teaspoon is 5 milliliters, that means that if we're dealing with water, 1 milliliter is only 12 drops. If you're looking at your medications, most of your drop factors are between 10 and 20 drops per milliliter. So things that are slightly thicker than water to things that are quite a bit thinner than water. There are more of these conversions in your book, but these are the ones that are really the most useful, most common. So with these conversions, like I said, the book gets kind of carried away with dimensional analysis. We brought it up a little bit with our miles per hour and stuff like that earlier. But we could run into things like, let's say we have 8 milliliters per minute. And I want to know how much, if it's infusing 8 milliliters per minute, how much can I infuse in 7 minutes? Well, again, the units will tell us how to make this calculation. 8 milliliters over 1 minute. I want to know how much, so I want this to become just milliliters, so I need to get rid of the minutes. To get rid of minutes, minutes better go on top. So I do have 7 minutes, like that. So I now multiply, the minutes will cross cancel, leaving me with just milliliters. 8 times 7 is 56 milliliters. 1 times 1 is 1. So I have 56 milliliters over 1, or just 56 milliliters. We could take the numbers out and just work with the units if we wanted to. Let's say that I have a certain number of minutes, and I want to know how many milliliters I can get in that time. So I'm going to take minutes divided by milliliters per minute. So that means I'm going to take minutes over 1, turn it into a fraction. When I divide fractions, what do? Multiply by a reciprocal. So I'm going to multiply by minutes over, I did that wrong. I wanted to have milliliters per minute, and I wanted to, I used the wrong units here. I had minutes divided by minutes per milliliter is what I was looking for. Sorry. So I'm going to take my minutes over 1, dividing by minutes per milliliter, I'm going to multiply by milliliters per minute. So now I'm looking at this, the minutes can cross cancel. I have milliliters on top, 1 on bottom, so it's just milliliters. It's Friday, the little hamster's taking off for the weekend again. Sorry about that. I might have a flow rate given in milliliters per minute. And I want to change it into drops per minute. So I might have my drops per milliliter, whatever that number is. Well, milliliters per minute times drops per milliliter. You can see the milliliters cross cancel. I've got drops per minute. One thing the book does, it's kind of silly. They use this notation, like a gram to the negative 1. We've already seen that power of negative 1. What does that mean? Well, a gram to the negative 1 is just 1 over gram, like that. So I have a gram to the negative 1 times a gram. We don't write it, but what's the power on this? It's 1. So there's two different ways I can look at this. I can work with powers like I did with my variables or powers of 10. When I multiply variables with powers, I add the powers. What's negative 1 plus 1? 0. So it's g to the 0 or grams to the 0 or just 1. Anything to the power of 0 is 1. Or I could look at this as being 1 over grams times grams, and the grams just cross cancel and I get 1. Now again, the book uses that gram to the negative 1, even though it's really a nonsense unit. It also uses liters to the negative 1 and centimeters to the negative 1 and all that. What it's trying to get you used to is this dimensional analysis like we did up here. These are more reasonable. These are units you may actually use in dimensional analysis. But to get you used to working with them, the book takes it to an extreme, and it gives you problems like this. Milligrams squared over liters to the negative 1, meters to the negative 1, times liters to the negative 1 over meters times milligrams. Well, here, first of all, I can cross cancel. My liters to the negative 1 can cross cancel. Milligrams squared, I'm going to write that as milligrams times milligrams, so that I can cross cancel 1 milligram here. So on top, all I have left is milligrams. On bottom, I have meters to the negative 1 times meters, which is just 1. Anything to the negative 1 times itself is just 1. So that reduces all down to just milligrams. Now, like I said, that's kind of silly to me, but let's take a look at another example. Centimeters over grams times milliliters to the negative 1 times grams over milliliters squared Let's see how this comes out. So if I look at this, first thing I can see is my grams will cross cancel. They're gone. Milliliters squared, I'm going to write as milliliters times milliliters. On top, I just have centimeters. On bottom, milliliters to the negative 1 times milliliters will cancel out. I still have milliliters, so I have centimeters per milliliter. This is one we will take time at the beginning of class before the test next week to go over any questions out of the homework that you have dealing with those. Like I said, the book takes it to an extreme. The last two examples I showed you to me are not very practical. What I showed you before with the milliliters per minute and minutes, drops per milliliter and stuff like that, those are more practical, but the book is trying just to get you good at it is all. Okay, our last thing for today is we want to look at converting temperatures. We are used to looking at temperatures measured in the Fahrenheit scale, in degrees Fahrenheit. The metric system uses degrees Celsius, or used to be called the centigrade scale. Both of them go off of two benchmarks. One benchmark is when water freezes, and the other benchmark is when water boils. In the Fahrenheit scale, what temperature does water freeze? 32 degrees Fahrenheit. Good. What temperature does water boil? What's that? 212 degrees. In the Celsius or centigrade scale, what temperature does water freeze? 0. Boils? 100 degrees Celsius. There are two things we notice here. One is the difference between them. There's 100 degrees between freezing and boiling in the Celsius scale. That's why it used to be called the centigrade scale, because it's centi means 100, grade means divisions, 100 divisions. There are 180 degrees between freezing and boiling in the Fahrenheit scale. So that's telling us that 1 degree Fahrenheit is smaller than 1 degree Celsius because it takes more of them to get from freezing to boiling. What makes temperatures more, bless you, what makes temperatures more difficult is the fact that they don't start at the same 0. For measurement length, 0 centimeters and 0 inches are the same length. 0 kilograms and 0 pounds are the same weight. 0 liters and 0 gallons are the same capacity. For temperature, 0 Celsius and 0 Fahrenheit are not the same temperature. They don't have a common 0 point. The only measurement scale that we deal with that does not have a common 0 point. So, to make our conversions, we can't just have an equivalency between them and use that conversion factor. We actually have to use a formula. So when we're making our conversions, the degrees Fahrenheit, if we're going from Celsius into Fahrenheit, our degrees Fahrenheit is equal to 9/5 times our degrees Celsius plus 32. So let's say we have a 20 degrees Celsius day. The weatherman says it's going to be 20 degrees Celsius tomorrow. Is that a nice day? Well, depends on who you are and what you think, I suppose. Well, let's convert it. That'll be 9/5 times 20 plus 32. Order of operations says we do 9/5 times 20 first, which is going to give us 36. 36 plus 32 is 68 degrees. So 20 degrees Celsius is 68 degrees Fahrenheit. To me, that's a pretty nice day. If I want to go from Fahrenheit into Celsius, our Celsius temperature is equal to our Fahrenheit temperature, subtract 32 degrees from it, and then multiply that difference by 5/9. So the one common temperature that we use, what is human body temperature in degrees Fahrenheit? 98.6. By the way, research has been done in the last 10 years that proves it's actually closer to 98.2 than it is to 98.6. I don't know if you guys have heard that before, but no. So anyway, let's make the conversion. 98.6 minus 32. Order of operations says we have to do the parentheses first. 98.6 minus 32 is 66.6. Then we're going to multiply by 5/9. 5/9 times 66.6 is 37. Correct? So, 37 degrees Celsius is human body temperature. I'm going to have you try one. I'm trying to think of winter coming up here. Let's take a negative 40 degree Fahrenheit day. What's that going to be in degrees Celsius? Give that a shot. So put it into our formula, going from Fahrenheit into Celsius. So it's our Fahrenheit temperature of negative 40 subtract 32, then we'll multiply by 5/9. So we start out, negative 40 minus 32 is negative 72 times 5/9, negative 40. Negative 40 is the one temperature that's the same on both scales.
Oh, that's what I got. I was like, how did I get Fahrenheit? Yeah. Good.
Okay, well, some pages out of the book that you should look at before next week. On page 103, 1 through 19, the odds. Page 110, 1 through 41, the odds. Page 114, 1 through 25, the odds. That is the dimensional analysis on page 114. Like I said, that probably will frustrate many of you. Next week we will take time before the test to answer that. Next week I plan on playing it by ear, by the way, with the test. If we have some time after the test, what we'll do is at the end of the first hour we'll decide whether we're just going to do the test and call it good, or if we're going to try to lecture. Some more on the apothecary units and temperature then. Page 118, 1 through 19, the odds. And page 123, 1 through 21, the odds. If you have the assignment sheet printed off from Blackboard, it's basically everything that's left in Unit 2. Like I said, next week we'll start out, we'll answer some questions at the beginning if necessary, we'll take the test. Then we will, like I said, at the end of the first hour, I'll decide either to let you go when you're done with the test or if we're going to try to put a lecture in the second half. With that, I guess I'll give you guys a little bit of hint as to what's on the test just so that you know what to study in case you forgot. Remember, things that we've covered in this unit, seems like a long one. Solving equations. You might have equations as complex as this. Asked to solve for x. Make sure you know how to do that. Remember our mixture problems with our different concentrations. If I have 12% and 18% and I need 16%, remember how to mix those. We're going to be looking at rearranging formulas. In a couple of senses. If I give you a formula like P equals I squared times V over R, and I give you that I equals 3, V equals 7, and R equals 21, find P, that you can solve to find P. Or I might give you a formula like D equals mv squared and ask you to solve that for V. So to get V by itself, you'd have to divide by m. So D over m equals V squared. And you have to take the square root to get rid of the squared. So V is equal to the square root of D over m. We'll have basic ratios and proportions, like from last week. You might have to reduce 35 centimeters compared to 56 centimeters. First thing is the centimeters would be gone, and both of those can be divided by 7, which would give us a 5 to 8 ratio. If we had 16 to 12, both of those can be reduced by 4, give me a 4 to 3 ratio. Would I change that into 1 1/3? No. A ratio is a comparison between two numbers. We never want to change a ratio to a mixed number. We have a proportion like we had last week, where we might have x over 7 equals 21 over 49. Find x. We're going to have problems with our percents and other things. Of course, word problems with what we've talked about. And then, of course, we're going to have a lot of, as we did today, those measurement conversions. Now, as I said, you can use your books on the test. I will also, with the test, I usually provide a sheet of conversions as well, so you don't have to dig through the book. But you can use your books and your notes on the test. That's what we have to study for the test. Like I said, we'll take time at the beginning next week to answer any questions. So you guys have a great week. We'll see you then.